Welcome to this lesson on how to change improper fractions like these to mixed numbers. And the first one, 3 over 2 or 3 halves. And a way of doing this, changing this to a mixed number, is to draw a diagram. And that's the first way I'm going to show you. So if I have 3 halves of some oranges, I can't have 3 halves of one orange because there's only 2 halves in it. So I need to draw more than one orange. So there's my blue orange, and there's another one, and I've divided them both into halves. So in this one there are 2 halves. I want 3 halves, so I'm going to color in one more. So I've colored in 3 halves, and you can see from that that is the same as one whole orange and one half. So I've really colored in 1.5 oranges here. So 3 halves is equal to 1.5. So for this one, I'm going to need 7/3 of some oranges. So I'm drawing more than one orange again. So there's 3/3 in that orange and 3/3 in this one, and that's a total of 6/3. So I need one more third and that one there. They're not quite thirds because these two are big pieces and that's a little one. They're supposed to be equal pieces. So I'll pretend they're thirds, and there's 7/3 colored in, and you can see that the 7/3 is the same as 2 whole oranges and 1/3 of an orange. So 7/3 is equal to 2 and 1/3. So that's one way of changing an improper fraction to a mixed number. It's not so good when you've got improper fractions like something like you might have 84 over 15. You could do it by drawing a diagram, but there's a shorter way of working it out, and I'm going to show you that way now. And I'm going to start with these same fractions, so 3 on 2. And when you have any number over a number like this, it can be read as a fraction or as a division sum. And when you read it as a division sum, you would read it as the top number divided by the bottom number. It's never the other way around. So this is 3 divided by 2. And another way of reading that is how many 2's in 3. And the answer to that question is, how many 2's are there in 3? There's 1, and there's 1 left over. And what number does it go over? It always goes over this bottom number here. And you can see from the diagram that the 3 halves that you had up here, that 1 stands for this whole orange here, and this 1 left over here has to go over the 2 because it's talking about this 1 left over piece here, which is 1/2 of that orange. So the short way of figuring out what this number is, it's always this bottom number here. And with 7/3, how many 3's in 7? There are 2, and there's 1 left over, and that goes over this 3. And same with that, the 7/3 over here, the 2 in this number stands for those 2 whole oranges, and the 1 that was left over is talking about this 1/3 that's left over, so it has to be a 3 anyway, just looking at the diagram. And again, short way is it's just this number on the bottom that goes on the bottom there. So a couple of harder ones. So the first one, 17 over 3. How many 3's in 17? There's 5 with 2 left over, and it goes over this 3. And so 17/3 is equal to 5 and 2/3. Another example, 18/5. How many 5's in 18? There's 3. 3 5's are 15, so there's 3 left over, and that 3 left over goes over that 5. So 18/5 is the same as 3 and 3/5. And if you're going to do this one, how many 15's in 84? I think there's 5 15's in 75, and then you would need 9 more to get to 84. So that's 5 and 9 15. So I'm just going to check that. So 75, 84. So borrow 1 from that. That becomes 14 minus 5 is 9. Yep, so there's 9 left over. And then 3 goes into both of those numbers. So that would be 5 and 9. How many 3's? And then 15. How many 3's? That would be 3/5. So that's how you would do this one. Much quicker way than drawing a diagram for it. So 84/15 is equal to 5 and 3/5. And so that's how you can change improper fractions to mixed numbers using a diagram. and also using a short method. And there's an exercise that goes with this. Just go to our website, sign up for the fractions course, and you can get the exercise for this lesson. And I'll see you in the next lesson.